All right, so this is part 2 of 4.3c particle motion revisited. I'm going to continue with the question shown earlier. All right, so I'm going to right now find my acceleration function. So I'm just going to build off of the velocity function that's right here. So I need to find this. I'm going to write it as the second derivative of the particle function, the particle position function, excuse me. All right, so my second derivative is 12t minus 28. All right, and so now I want to find the values of t. I'm looking for points of inflection, so I'm going to find the value of t that makes this function here equal to 0. All right, so I'm going to add 28 over here and divide by 12. And I get t is equal to 7/3 or 2 1/3. Okay. So now what I'm going to do, I'm going to make another t chart or sine chart, and I'm going to put my sine chart directly underneath the sine chart that I have right here. So it still starts at 0 time. And the only point of inflection that I have, or critical point that I have, is at 7/3 or 2 1/3. So I'm going to put that it's about right here. And I'm going to complete my sine chart. So if I plug in the number 1 in here, then I get a negative output. So I'm going to write negative here. And if I plug in a number bigger than 2 1/3, so like 3, I'd get a positive output. So I put a plus right there. Okay, so now I'm going to end up writing out my analysis of when the particle starts, what direction it goes, when it stops, and moving left and right, etc. And then I'm going to look at my graph here, my sine charts, to determine when the particle is speeding up and when the particle is slowing down. So next what I'm going to do is go ahead and write out the direction that it's moving. So I'm going to get rid of this really quick. All right, so here's how we write it out. The initial position of the particle is x of 0 equals -5 feet. And according to my sine chart for the first derivative here, the particle moves right until it stops at x of 1. So what I have to do, this is showing at time 1, it moves, or it stops, but I need to find the output when t equals a 1. And if I plug in 1 into my position function, I end up getting 5. Oh no, yeah, 5. That's what I have written here. So then the particle moves left until it stops at x of 11/3, and that value is -13.962 feet. So that's approximate. And moves right thereafter. So there's the description with the motion. Scoot that up. There we go. All right, now I have to talk about if it's speeding up or slowing down. And here's where I need to look at the sine chart that I have here. So what I like to do, if I line it up this way, I split it wherever these critical points are, or when it, and let's see. So that's going to be positive, negative until this point. So that's at 1. So that's opposite signs there. Then it stays negative negative, and it changes to positive there. So I'm going to put another little dashing line here and then another little dashing line here. All I'm doing is separating when the signs of my velocity and the signs of my acceleration change. So what I'm looking for is when is my particle speeding up? Now it's going to speed up when my velocity and my acceleration have the exact same sign. So right here they do not. This one's positive, or the velocity is positive, the acceleration is negative. Then I see here it's negative, the velocity is negative, and my acceleration is negative. So this is from 1 to 7/3. Then they're opposite again, and then they become the same right here at 11/3. The velocity is positive and my acceleration is positive. So that's from 11/3 to infinity. Now for slows down, I'm looking to see when the signs are opposite. So that's from 0 to 1. And then it's the same here, and then they're opposite from 7/3 to 11/3. Okay, and I'm done.